Hello, this is Mrs. Slater again, and we are going to fast forward to 10.6 in identifying conics from their equations. First of all, quote, "It's hard to be humble when you're as great as I am," Muhammad Ali. All right, so if we're identifying conics, the reason we're skipping this is because in a couple years you're going to be in your math class and you're going to be studying a lot about conics, and we're just going to hit a little bit. We hit a lot about circles, and then we're just going to hit a little bit more about the ellipse, hyperbola, and the parabola. Now, as you're aware, also we have a what's on the front of your page looks like this of your worksheet. So if you slice the cone parallel to the base, we know you create a circle. If you slice the cone at an angle, you get this ellipse. And if you slice it at a side on just one cone, you get a parabola. But if you slice both of them perpendicular to the base, you get the hyperbola, creating the two little arcs. So then when you refer to this, you can kind of see where these pictures are coming from. Now, I do encourage you to explore the website, and I don't know if you can actually click on it because with the videos, I don't know what's going to happen. But if you do get it to work out, it looks something like this, where if you take the circle and move around the radius, we know that if you move the radius, there we go. If you move the radius, it's going to make it a larger radius versus a smaller radius. If you move h, which is this red number, it's going to move it to the left and to the right, based on if it's a negative or positive number. Okay? And then this one, this is going to move it up or down, because that's the k value. It's with the y. So that's cool, and you can play around with that. But the other ones that I want you to look at are like a vertical parabola. These are the ones we've been doing in class. Look at the form. You can see that. It's just going to expand, make it skinnier, wider, narrow. The k value is going to move it up or down. What's inside the parentheses is going to move it left or right. So there's just different things I want you to discover. Parabola we're more comfortable with, but like hyperbola, what actually happens when you make a new one? It's going to go left or right, or it's going to, I'm sorry, go up or down because it's y equals, and it's left or right when it's with the x equals. What if that number's bigger? What's going to happen? What if that number's bigger or smaller? What's going to happen? So again, I encourage you to take a look at that and see what you think. It's pretty interesting. Okay, so then let's go back to identifying. We know the standard form of a circle is right here in the rectangle. And then you've got the ellipse, a little different just because we've got the subtraction signs at the top. It equals 1 instead. Okay, so that's different. And then you have this a squared and b squared in the bottom. So just kind of take note of that. And then this one, you have squared terms again. But the main thing that stands out is the fact that you've got a negative sign right there. So that's what a hyperbola is going to do. And then this one, this last one over here, the parabola, you don't even have any squared term. You just have the one squared term, and that's it. So other ones you're going to see, if you play around the website, is you'll see ellipses that are more elongated. And then you'll also see hyperbolas that are going to be opening left and right. And then back to our past chapters is that parabola can either go up or down. This one can also go to the left as well. So there's different formats of what you're going to see on that website. The summary, if you just look at what you have, and you have one squared term, that is going to be a parabola. So go ahead and write that in your notes. Okay, and then if you have x and y terms with opposite signs, like I pointed out before, it's going to be a hyperbola because there is that minus sign, two x and y terms. Here again, x and y terms, x and y terms. So those are all going to be the same. Now, this one says same signs, different coefficients, different denominators. So that's going to be the ellipse. That's what's going to make the difference there. And then a circle has the same sign, same coefficients and denominators. So that's going to be our circle, which we're most familiar with. All right, so let's see if we can identify some of these. Go right to the squared terms. You don't even have to look at the rest of it. They are two squared terms. There's a plus sign, and they're different. So that's an ellipse. Okay, the next one, look, go right to the squared sign. They are the same. -3 and -3, so that means it's going to be a circle. If they have the exact same signs, same coefficients, which they do. Okay, squared terms, there is only one of them, so it can only be a parabola. Okay, let's see if we can get the next one. Here we go, opposite sign. So then, and then you have two different coefficients. So that's our first hyperbola as an example. All right, go ahead and push pause, and then that way you can check your answers. Okay, the next one, excuse me, is going to be a circle. Same side, same sign, same coefficient. There's only one squared term, so that's going to be a parabola. This one, they're the same coefficient but different sign. So that would be a hyperbola. And this one, we have different denominators with a plus sign, so that's an ellipse. And then this last one, we have an opposite sign, so that's going to be a hyperbola. All right, so hopefully you'll be able to identify conics now after looking at all of that. Okay, we're also going to do 10.7, which is this. We're going to solve quadratic systems graphically and algebraically. And let's see, where's it? Our goal is going to be to find the intersection of conics. Okay, so the first one is a line. There's no squared terms at all, so that's just going to be a line. This one, there's one squared term, and that's a parabola. We know how to graph both of these, so let's go ahead and do that. Y equals x means that they're always going to be the same, so you have all of these points, and the more the merrier. You can make a nice pretty graph by connecting all of those. And then a parabola, which is going to be x squared. It's going to be right here, over 2, up 4. Hopefully you haven't forgot how to graph that. And voila. Now, mine kind of intermixed together, but you can see that they intersect in two spots. One is at the origin, and the other one is right there. I don't know if you can see it, but it's at 1, 1. And then there's nowhere else that it would connect. And again, bad graph, but there is only those two places where it's going to hit. And hopefully your graph looks a little better. All right, now the next one. This is a circle. Now that we know how to identify them, this is a line. There's no square terms at all. Okay, so let's start with a circle. You have a 0, 0 center point and a radius of 5. So I'm going to put 5 up, 5 down, left and right. Connect them with a circle. Looks something like that. And then the line, we can't really graph it the way it is. So we're going to solve for y. So that'd be negative 4y equals a negative 3x. Divide both sides by negative 4. And we get y equals 3/4 x. Nothing in the back, so that must mean that our y-intercept is at 0. So we're going to go up 3. We're going to go up 3 and over 4 and try to find some connections. And then down 3 over 4. And that's where our circle is going to be. So let's go ahead and label those. It would be at 4, 3. That's going to be our first intersection point. And then the other one's down here at negative 4, negative 3. Okay, and then if you ever want to check, you can take both of those, plug it into both of those, and see if it works for both. All right, so let's go ahead and go to the next one. We have another circle. And we have a parabola. And if we're going to solve by graphing, you have 3 in every direction. So do your best circle. And then a parabola, we know goes up 1 over 1, up 2 over 4. And this one is not as nice as our last one. It's hard to tell where they exactly meet, and they should be symmetrical, and mine do not look symmetrical. So let's just make a guess right now, and then we'll go to the algebraic method, and we can see exactly what it's going to be. So our guess, make sure you make that a note to yourself that we are just guessing here. It looks like it's over a negative like 1.5. And then it looks like it's up 2.5. And it should be symmetrical. My picture's all not that great. So if it's symmetrical, then the other side would be at 1.5, 2.5. So we're going to go with that, and then I'll show you a little bit of the algebra that's behind it. If you can't tell, then you would try to solve algebraically, which requires some substitution method. Okay, so underneath it, we're going to do the exact same thing and prove that those are indeed correct. So by substitution, I know that y equals x, so therefore I can, okay, so by substitution, we can take x and plug it in for this one, because they equal each other. And if you want to solve it for 0, or set it equal to 0, you're going to want to do that. And then factor. And then use a little zero product property, because you have x equals 0 and x minus 1 equals 0. So x is going to equal 0 and negative 1. Okay, so that doesn't answer the question yet. We are going to have to do a couple more things here, which is to say that the first order pair would be 0 comma something, and the other one would be negative, because they're saying those are the x values of the intersections. So if we take that and plug it back into the first one, 0, the answer would be 0. If you plug a negative 1 in for x, the answer would be negative 1. Now we have a match, and I see I made a mistake, so I'm going to go back here, and that should have been a positive 1, and those should all be positive 1. So you probably already caught that, so I apologize for the confusion. All right, now let's go on to the next one. Again, we're going to try substitution. We want to get 3, 4, and negative 3, negative 4. Let's see how to do this. First of all, plugging, go back to what you had before, because y equaled 3/4 x. So we might as well use that. Take that and plug it in right here for y. So you have x squared plus 3/4 x squared equals 25. And if you square this, it would be 9/16 x squared. And this is 1, so that would be 16 over 16, which is 25 over 16 x squared. And if you multiply both sides by 16 over 25, 16 over 25, those cancel, giving you x squared all by itself, equaling 16. So what we have just discovered is that x would equal plus or minus 4. So let's use that now for the ordered pairs. One of them is going to be 4. One of them is going to be a negative 4. Okay, so now we're going to take the 4 and plug it back into one of the original equations, like this one. 3/4 times 4 is 3. Cool. The next one, we have 3/4 times negative 4. Hey, that's negative 3. That's what our ordered pairs were to begin with. So let's go on to the next one. And this is the one where we had to estimate, so let's see what we come up with. Y x squared, those are the same, so I'm just going to plug a y in for that spot. Okay, you're not going to be a big fan of this just because we've got a lot of things going on. Nothing factors nicely, so we are going to have to use the quadratic formula. And since we are in terms of y, I'm just going to say y equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So we have 1 plus or minus. That's all going to be 37. And then that's what they're saying the value of y is. So your two forms are 1 plus root 37 all over 2 and 1 minus square root of 37 all over 2. Okay, so kind of crazy, but if you do the math, that actually is 1 point. Nope, I got to rewind here. If you did the decimal of that, that is 2.54. Very close to what we estimated. And if you plug it in to the y value right here and take the square root of that, you're going to get plus or minus 1.59. Again, that's what we had gotten on our problem. We had a 1.5, 2.5, and we had a negative 1.5 and 2.5. So that's two ordered pairs right there. Now if we do the same thing to this one, if we take it and plug it in for y, again right here, and take the square root of it, we're going to end up with a nasty number. And you know what? Real quick, I made a mistake. That should be plus. That would be minus. That'd be minus, 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 and that would be 2.54. So I'm glad I found that mistake before we ended here today. So if we take that and the square root of that, it is an imaginary number. So we can conclude with, yay, we got the right answer. That's going to be the intersection point, and just by guessing. Okay, time is up. So 7, 8, and 9, we're going to begin class with those tomorrow. So if you have any questions, please let me know.